The topic I'm going to discuss with you today is eco-driving, and we're going to discuss it from a psychological perspective, the perspective of behavioral economics. But on top, we're also going to use the framework of user energy interaction. So those are quite a few maybe unfamiliar concepts to some of you, so I'm first going to introduce them. As you can see in my agenda, we're starting with eco-driving, user energy interaction, behavioral economics, and finally I'm going to introduce a control theoretic framework, which includes most of them. Yes. We also have a special guest. It's an interested eco-driver, and he might have some questions what you should do in different situations. So let's see. Eco-driving encompasses, in general, different driver behaviors that are targeted towards increased energy efficiency. So these behaviors are not limited to behaviors on the road. They also include strategic, tactical, and operational levels of eco-driving. What do these levels mean, or what do they include? On the strategic level, we have things like, for example, purchasing a new car. So I have a purchase decision, and I can decide to choose a more energy efficient vehicle. And Shivak and Shepley have estimated that if a driver purchases a normal vehicle compared to a pickup truck, he or she could save about 38% in energy and fuel. On the tactical level of eco-driving, we have things like route choices, and also we can make substantial energy savings on this level. And finally, on the operational level of eco-driving, we have the on-road behavior. So the 10% refer to the reduction in CO2 emissions that could follow a behavioral change on this operational level of eco-driving. And for fuel consumption, it's nearly the same, the number. The driver, or interested eco-driver, might have different questions regarding each level. On a strategic level, he might ask, with which vehicle can I achieve optimal energy efficiency? On a tactical level, he might ask, how much can I save with a different route? So if I, for example, drive 5 minutes more, how much energy can I save for this 5 minutes if I take a rural road instead of the motorway? And on the operational level, he might ask, how can I drive energy efficient on the road? The operational level is also what we target when we speak about user energy interaction. User energy interaction is driver interaction with the vehicle's energy dynamics. Finally, the reason for this is, or the reason for the importance of user energy interaction is that we have primary energy such as fuel or electric energy in electric vehicles, which must be converted into mobility. So we want to convert these primary energies into a certain driving distance. And this is done via kinetic energy. So primary energies are converted into kinetic energy, which creates our mobility. And if we take this perspective on eco-driving, this user energy interaction perspective, we can see that eco-driving is essentially dealing with the energy resources. Our eco-driver might have some difficulties now because the whole thing becomes quite complex, and he might face different questions. For example, for acceleration is not only acceleration is converting fuel or electric energy into kinetic energy with probably with the goal of accelerating the vehicle, of converting as energy efficient as possible. The same question, he might face the same question for eco-driving, for the deceleration, I'm sorry. So when we decelerate, we have to utilize the kinetic energy we have already built up as energy efficient as possible. So if we, for example, use the brakes, we convert this kinetic energy into heat energy, and it's at least most of it is wasted. So drivers have to make economic decisions on the road and user energy interaction and eco-driving can both be regarded as on-road economic decision-making. A framework for this economic decision-making from a psychological perspective is behavioral economics. And a theory which is quite basic and quite important for behavioral economics is the prospect theory. The prospect theory is a very big framework. I'm only going to focus on the aspects which are important for our work. So we first have, we distinguish into editing phase and evaluation phase. In the editing phase, the decision alternatives, for example, different acceleration strategies, they are prepared for the further decision. So we have to gather information about the decision alternatives. In the evaluation phase, a utility is given to each decision alternative, which means that we give them a certain value. And at the end, we choose the decision alternative which has the highest value. This is not always done, so this is a bounded rationality theory. So it might sound like the decision is quite rational, but indeed it is not, because humans do not gather all the information. They use heuristics, which are rules of thumbs, and they apply them to edit the decision alternatives. So those are not, they do not gather all of information. They focus on certain aspects of each decision alternative based on these heuristics. And a second aspect which influences the decision is framing. Framing is the way a decision problem is formulated. So we might have certain frames, for example, in the vehicle through the user interface, and the heuristics refer to the internal part of the human, whereas the framing refers to the external part. So this is quite important when designing, for example, eco-driving support systems. We should consider the human, we should consider the heuristics humans use, but we should also design, we should also frame in order to make, to empower them or to enable them to use their heuristics in a positive, energy-efficient way. We have developed a control theoretic framework together with Rich and Neville, which includes these things, but it's quite complex, so I'm just going to focus on the most important aspects of it here. We have driver characteristics. We have, on this part, we have the implementation of the selected strategy. So a strategy, eco-driving strategy, is selected and implemented, but it's not a focus here. We also have the driving environment, and the outcome of everything is the fuel efficiency, which we can see here. So it's a framework which shall describe eco-driving behavior. What is important for us is that we have system variables, especially the user interface informations, which provide the frame for our eco-driving decisions. And we also have the perceived strategy effectiveness, from which an subjective expected utility is derived for each strategy, so for each decision alternative. And the perceived strategy effectiveness for each strategy is something like the outcome of the editing phase from the behavioral economics. So we have to consider, in this respect, which heuristics do humans use to edit the decision alternatives, which are eco-driving strategies in our context. And we also have to consider how do we frame these decisions? How do we frame the strategy effectiveness of different strategies? So this is something we are currently exploring, because the work of behavioral economics is not really considered until now in the eco-driving context. So I was conducting a first literature review, a very small one only, in our paper, which is published in the conference proceedings. So if you would like to have more information on that, you can just read the paper. I can also give it to you. And here I'm going to focus one heuristic. It's a time-saving bias. This heuristic rather refers to a general context of driving and is not really eco-driving specific, but it also has some implications for eco-driving. The time-saving bias is a bias that occurs when humans shall save the time, shall estimate the time they can save when they increase the speed from a certain initial speed level to a target speed level within a certain distance. So in this figure, humans were asked to estimate the time savings when they increased the speed for 10 kilometers per hour for a driving distance of 50 kilometers. And what we see, it's a typical bias that humans underestimate the time savings. So the black line are the real time gains, and the dotted line is the perceived time gain. They underestimate the time gains when starting from low initial speed levels, and they overestimate them. This is what we can see here, the difference, when they start from a higher speed level. And this is the proportion heuristic they apply. And this proportion heuristic leads to a biased evaluation and probably also to biased decisions, which might be quite difficult in the eco-driving context, because especially at high speed levels, the fuel consumption goes up quite fast. It's an exponential growth in the fuel consumption. So they overestimate their advantage in time savings, which could lead them to more likely apply higher speeds, which could lead to far more increased energy consumption. But there's also a way to frame this differently, which can reduce the time-saving bias. This is a paper by Eriksson et al. They have developed an alternative speedometer, which does not show the kilometers per hour, but instead the minutes per kilometer. We call this pacemeter in the following minutes. And they have conducted an experiment, a driving simulator study, where they first, all participants had to drive with a conventional speedometer. One route was with a low average speed and it was not so long. And the other route was with a higher average speed, but it was longer. Afterwards, one group of participants additionally received the pacemeter, and the task was given to them that they should drive faster in order to reach time savings of 3 minutes. The same task was also given to the second group, but they did not receive this pacemeter. They only had to base their decision on the speedometer, on a conventional one. And what we can see, I have just included the line for 3 minutes here. The green group is the pacemeter group. Their time savings they achieved in the driving simulator task, they are less biased than for the conventional speedometer group. So there's a way, if we frame a problem differently, that humans can apply their heuristics in a more adequate way, we can achieve less biased decisions and less biased behavior too. This also leads me to my implications. First of all, I and Thomas and I, we proposed that behavioral economics is a useful framework for user energy interaction. And user energy interaction is one aspect on the operational level of eco-driving, which might be really interesting. Second, we should design eco-driving support system with the driver's heuristics in mind. So we should understand that we cannot change the driver's heuristics. We have to understand them, and then we can use framing as a solution so that drivers can apply their heuristics in an adequate way, so that their heuristics lead them through the framing of the system to energy efficient behaviors in the vehicle. So thank you for your attention, and I'm happy for any questions that might arise.